So yeah, welcome to Science Planet, and today we are trying to analyze the titration of NaCo 2025. And here you can see our titer value to be 26.30 cm3. We have already done our titration, and you can see the table up there. Okay, now please, before I proceed, subscribe to this channel if you're a new member. Subscribe to this channel and share. Turn off the notification bell. Let's go. They said A is a solution of 0.100 mole per dm cube of HNO3. B is a mixture of 8.0 gram of sodium triazo carbonate 4. Okay, just take time to read this. Okay, and let me say something before I proceed. You see, we said that this is a mixture. That is our B. Our B is a mixture of sodium triazo nitrate and sodium triazo carbonate. Please take note that the sodium triazo nitrate, that is the NaNO3, is just acting as an impurity. It will not react with the acid. The only substance that will react with the acid is the sodium triazo carbonate. It is only sodium triazo carbonate that will react with acid. The sodium triazo nitrate will not react with the acid. It is only acting as what? As an impurity. So that is why in the equation for the reaction you are only seeing HNO3 plus Na2CO3. You didn't see the sodium triazo nitrate in the equation for the reaction because it does not react. It's just acting as an impurity. So you can see our question number 1, question number 2, and question number 3. Okay, and even question number 4 and 5. We have 5 questions here. So we want to calculate the concentration of B in mole per dm cube. Concentration of B in mole per dm cube. Yeah, first of all, let's write the equation for our reaction, although it has already been given to us, but let's write it. So 2HNO3 aqueous state reacts with Na2CO3. I know some of you will be wondering, why am I using only sodium triazo carbonate? Remember, yes, our base is a mixture of sodium triazo carbonate and sodium triazo nitrate, but the truth is that the sodium triazo nitrate is just acting as impurity. Yeah, it's just acting as impurity. It doesn't react with the acid. It does not react with the acid. So in our equation for reaction, we are not going to include the sodium triazo nitrate. So in that case, we have 2NaNO3 plus H2O, water, and carbon dioxide, that's CO2, all in aqueous states. Okay, so in calculating the concentration of B in mole per dm cube, you are going to use our CaVa equals to Na over CbVb over Nb. Okay, you know your Ca is the concentration of the acid, and the concentration of acid was given as, in the question, 0.100 mole per dm cube. Okay, so 0.100 mole per dm cube. Then, okay, our volume of acid is your titer value. Okay, my titer value, I got 26/30, that's cm cube. Okay, then my Na, number of mole of A, my A is acid. You know, the first one is your A, the second one is your B. So my A is my acid, and the number of mole is 2, so equals to 2. Then my Cb, concentration of B is what I'm looking for, so equals to, that's what I'm looking for. Then my Vb, volume of base is your pipette, the pipette you use to pipette your base. So I use 25. You know, we are asked to use either 20 or 25, so I use 25. Then your Nb, number of mole of B, which is 1. Okay, so equals to 1. So inputting this, my concentration 0.100 times my volume of acid, which is 26.30, equals to my number of mole of acid A over my CB is what I'm looking for, times my volume of base, which is a 25, right? 25.00 over my number of mole of B, which is 1. So when you cross multiply, you are going to have 0.100 times 26.30 times 1 equals to CB times 25.00 times 2. Oh, where's my 2? Times 2. So making CB subject of formula CB, you have 0.100 times 26.30 times 1 over 25 times 2. Okay, where's my calculator? So it should be giving you equals to okay, let me write it here, equals to 0.0526 mole per dm cube. Okay, so this is my concentration of B. So let's look at the next question. So the next question says mass of NaNO3 in sorry, that's not our second question. Our second question says mass of Na2CO3 in 250 cm cube of B. Okay, so this particular question is simple. You don't need to panic. Remember, we have our Na2CO3, that's our sodium carbonate, in mole per dm cube. In mole, we have it in mole as 0.0526. Remember, our B is this. Our B is the sodium triazole that's our B, because I told you the sodium triazole doesn't react. So if you look at the equation, this is our B. So we have it in mole. So let's convert it to what? To mass. Let's convert it to mass in gram per dm cube. Then we now solve it using 250 cm cube. Remember, it is in 1 dm cube. 1 dm cube means 1000. So let's convert this mole to mass first in 1000. Then we now solve using 250. Okay, so in converting mole to mass, you use mass equals to mole times what? Molar mass. So the mole of sodium triazole carbonate times the molar mass of sodium triazole carbonate. So let's calculate the molar mass of sodium triazole carbonate. Let's calculate it. So in calculating the molar mass of sodium triazole carbonate, so this is our formula, sodium triazole carbonate, right? So our sodium is 23, there is 2 in front of it, times 2 plus our carbon is 12 plus oxygen is what? 16 times 3. Okay, so equals to 23 times 2 will give us 46, yes, plus 12, 16 times 3 will give us, I think, 48 or so. 16 times 3. Yeah, 48, I'm correct. It was 48. So add up this together. 46, right? 46 plus 12 plus 48 give us 106. So equals to 106 gram per mole. Please don't forget to put your unit. Each unit carries mass, gram per mole. So in that case, our mass of Na2CO3 will be our mole, which is 0.0526. 0.0526 times our molar mass, which is 106. Okay, so 0.0526. So it will give us equals to 5.58 gram per dm cube. Okay, this is not the final answer. Remember, this gram is in dm cube, that is, this gram is 1000 cm cube, but the question is what? The question is mass of NaCO3 in 250. So in that case, if we have 5.58 gram is in what? Is in 1000 dm cube. What mass will be in 250 dm cube? As simple as that. Yes, they asked us to calculate the mass of sodium triazoyl carbonate in 250 cm cube. So we have our mass in 1 dm cube, which is still 1000. So if this 5.8 is in 1000 dm cube, what will be the mass in 250 dm cube? So you cross multiply in 250 cm cube, cm cube. Okay, so you cross multiply. When you cross multiply, you have your x times 1000 to give you 5.58 times 250. So making x subject of the formula, you have 5.58 times 250 over 1000. Okay, so punching your calculator very fast. 5.58 times 250 equals divided by 1000 equals to 1.39. So let's make it 1.4. I think it's better, 1.4. So equals to 1.4 gram in 250. So our answer is 1.4 gram. Okay, so I hope you are following. So our next question, number 3, is mass of sodium triazoyl nitrate in the mixture. So you don't need to panic at this particular question. Mass of sodium triazoyl nitrate in the mixture. What is the mixture? Let's go back to our question. We are told that B is a mixture of 8.0 gram. It's a mixture of these two. It's a mixture of sodium triazoyl carbonate and sodium triazoyl nitrate. So the two mixture is what? Is 8.0 gram. So that means mass of NaCO3 plus the mass of NaNO3 give us what? Give us 8.0 gram. That is what is in the mixture. Then if we know this mass, if you know the mass of NaCO3, then we minus it from the total mass. Then we can get the mass of sodium triazoyl nitrate, that's NaNO3. Thank God we have solved for the mass of sodium triazoyl carbonate. Come here. The mass of sodium triazoyl carbonate, we solved it as 5.58 gram per dm cube. Yes, this is the mass. You see the mass of sodium triazoyl carbonate is 5.58 gram because it's in dm cube. So we now say 5.58 gram plus the mass of sodium triazoyl nitrate equals to 8.0 gram. Then collect like terms, NaNO3 will be equals to 8.0 minus 5.58. So minus it. NaNO3 will give us what? Give us our calculator. 8.0 minus 8.0 minus 5.58 will give us 2.42. Was 2.42 what? 2.42 gram. Haha. As easy as what? ABC. As easy as ABC. So let's go to the last question. Is it the last question? No. That is the percentage purity. Yeah, that's the second to the last question anyway. So our IV, we have the percentage percentage purity of sodium thiocarbonate. If you know the percentage purity, it's very simple. The formula, what is the formula for percentage purity? Let's bring out the formula first. Percentage purity is equals to mass of pure over mass of impure. Mass of impure. I remember our mass of impure is the mass of the mixture. It's also the mass of the mixture. Okay, so that is the mass of impure. So times 100 over 1. That is percentage purity equals to mass of pure over mass of impure times 100 over 1. So what is the mass of our pure? That is, just get the mass of this Na2CO3. Okay, and we have our mass. We have our mass of NaCO3 to be 5.58 gram. Okay, so percentage purity is equals to 5.58 gram over mass of impure. What is our mass of impure in the equation? The mass of impure in the equation is 8.0. You can see that I told you that the mass of impure is the mass of the mixture. Mass of the mixture. That is the impure, the mixture. Okay, so 8.0 gram times 100 over 1. So when you divide this, you will get, okay, let's do it. So you have your 5.58 divided by 8.0 equals to times what? 100. to give you 6.9. 6.9 is the same as 70, so it will give us 70%. Please don't forget to put your percent because you are looking for percentage purity. Okay, that's your percent, don't forget that. Okay, for our last and final question, which is number 5, we are looking at the percentage impurity. Please, this one is impurity. So percentage impurity of our sodium triazonitrate. Our percentage impurity of our sodium triazonitrate. So the formula is still similar. So percentage impurity is equals to percentage impurity of this. So is the mass of this, mass of NaNO3 over the mass of the mixture or the mass of the impure, anyone, that mixture or the impure, times 100 over 1. Okay, so equals to, what is our mass of this? Remember, we solved it now. We solved it at question number 3 to give us 2.42 gram. So 2.42 gram over mass of impure, which is 8, times 100 over 1. So when you punch your calculator and every other thing, you should be getting 30%. So I believe with this likely question. You have understood everything about NaCo quantitative analysis, NaCo 2025 quantitative analysis. Please do well to subscribe on this channel. Very important. And you can share it to your colleagues. You can share it to any student that is writing the NaCo 2025. Thank you very much.